For the GCSE exams, you're expected to remember all of these trig values. Don't bother. In this lesson, I'll show you how to work them all out within minutes, should they ever come up in your exams. Hello, and welcome to this video on exact values. This is a part of trigonometry that you'll be expected to memorise for your non-calculator paper. In this lesson, I'll show you why memorising it is not the best strategy. Once again, make sure you check out Mathsquared.org for all the extra resources. Now, for the 0 degrees and the 90 degrees values, it will be better to learn them by understanding the graphs. We'll do this in a different video. Today, I'll show you a quick way to memorise all of these in between. So rather than memorising a whole table of values, all we have to learn is two triangles. This is going to be much easier. We can start with the isosceles triangle. We're going to take this right angle triangle and set two of the sides equal to 1. If one angle is 90 degrees and the other two are going to be the same, can you see that these angles will be 45 degrees? To work out the third length, we'd use Pythagoras' theorem. So a squared plus b squared equals c squared, and a and b are both going to be equal to 1. After a bit of rearranging, you should see that c will be equal to the square root of 2. We can now consider some trig functions. We can pick either of these angles to focus on because they're the same. We can work out what sine 45, cosine 45 and tan 45 will be equal to. Remembering SOHCAHTOA, you can see that sine will be equal to the opposite over the hypotenuse, cosine will be equal to the adjacent over the hypotenuse, and tangent will be equal to the opposite over the adjacent. So plugging these in, noting that the opposite and the adjacent are both 1 here, we get the following. And in that we have derived these three values here. In the other triangle example, we can derive the other two columns. Here we have an equilateral triangle. What do we know about equilateral triangles? Well, they have equal interior angles and equal side lengths. And if the angles are all equal, then they're all going to be 60 degrees, since the interior angles must add up to 180. For the purposes of this exercise, we're going to say that all of the sides are equal to 2. Now we've defined our equilateral triangle, we're going to divide it in half to make it a right-angled triangle. This is because we can only use trig like this on right-angled triangles. Now, because we've halved the triangle, are you happy that the bottom length will now be equal to 1? We're also going to need to use Pythagoras again to work out the length of this new side. In this case, we already have the length of our hypotenuse, c. We can also set a or b to 1. In this case, we'll set a to 1. After a bit of rearranging, you should see that b is equal to the square root of 3. Now the first thing we can consider is the 60 degrees. What will sine of 60, cosine of 60 and tangent of 60 be equal to? Again, considering SOHCAHTOA, we know that sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, and tan is the opposite over the adjacent. As our angle is 60 degrees, our opposite will be the square root of 3, the adjacent will be the 1, and the hypotenuse is, of course, 2. Plugging these in, we get these as the following exact values. And just like that, we've worked out 3 more exact values. And finally, using the same triangle, we can work out these last 3 exact values. So we've shifted our focus from the 60 to the 30 degrees. Note that our opposite and our adjacent are also going to switch places here. So the same as before, we're going to work out our sine of 30, our cosine of 30 and our tangent of 30 using the SOHCAHTOA rule, and we should get these following exact values. Note that for tan 30 we're going to get 1 over the square root of 3. Now we're going to rationalise this denominator by timesing top and bottom by the square root of 3. Now don't worry if this step doesn't quite make sense, as we'll be covering this in more detail in a lesson on surds. And there we have it, we've worked out the last 3 exact values. Now you might be thinking that this is not an easier way to memorise the values. I advise you to go away from this lesson and try and follow the steps that we've been through here. Try drawing both types of triangles and thinking through each step. This will really help, and I assure you that you'll find it easier for your exams.